Okay, dear students, let's have a look into the third case where a proper fraction is there and one of the factor in the denominator is a quadratic factor. And this quadratic factor is such that it cannot be further factorized. So the general form of this type of a fraction and its partial fraction is given by px plus q over ax plus b into cx square minus t plus t, cx square plus t. So here you can see that this one is the linear factor and this is the quadratic factor cx square plus d. So the partial fraction of this one will be equal to a over ax plus b, a over the linear part, plus bx plus c over cx square plus t. So bx plus c over the quadratic part. So this is important to remember that when there is a quadratic factor in the denominator, at the top there are two variables b and c such that bx and then c is without x. So b is with x and c is without x. So this is the general form of this type of fraction where one factor is a quadratic factor. So let's have a look into the example. Here, express 8 plus 2x minus x square divided by x minus 1 into x square plus 2. So this is the quadratic part here, and we have to express this one in partial fraction. Remember that in the first two cases, we have used a method to solve or to find the partial fraction, and that method is simply called the substitution method. We just found a value of x from the denominator and then substitute that value in the given equation to get the values of unknown variables a, b, c, etc. And then we at the end find the partial fraction and rewrite the expression in the form of its partial fraction. In this case, however, we will use the substitution method, but with substitution method, we will also use at the end another method which we already have discussed earlier, and that is the comparing coefficient. And we will see that why we need these two methods basically in order to solve this type of algebraic expressions into partial fractions. So let's start. The equation is given here, the expression is given here, 8 plus 2x minus x square divided by x minus 1 into x square plus 2. And we can write it down therefore using this approach, a over linear part plus bx plus c over the quadratic part, x square plus 2. Now if you multiply each and every term by this denominator, so here we'll get 8 plus 2x minus x square, and here we'll get a into x square plus 2 plus here we'll get bx plus c into x minus 1. So if we further simplify it, we can do that one, but at the moment we don't need to further simplify it. We can see that from the denominator we have x minus 1 is equal to 0. It means that we can easily insert x is equal to 1. Let's say this is our equation number 1. So when we insert x is equal to 1 in this case, you can calculate it. You will find the value of a is equal to 3. So this is our first variable a. We still have two more variable b and c. So the second part here in the denominator is x square plus 2. So if I say x square plus 2 is equal to 0, I can get x square is equal to minus 2, which we cannot solve, right? So here is the problem. Okay, we'll come back to this one in a while. But now, as in the previous case, we also can use x is equal to 0. So use x is equal to 0. So once you use x is equal to 0, you will get the value of c after you solve it is equal to -2. So you can see that if we use x is equal to -1, we can we work out value of a. When we use x is equal to 0, we get the value of c, but still the variable b is missing. Okay, so never use this part. Okay, this is not required because it will lead to undefined answers in many cases. So what to do in order to work out the value of the last variable, which is b? So here now we will again go back to our equation 1 and simplify it such that we can then compare the coefficients. So our equation 1 is, you can see it is 8 plus 2x minus x square, and then open the brackets. A into x square is ax square, a into 2 is 2a, and now multiply out these brackets. B x into x is bx square minus bx plus cx plus and minus c into -1 is minus c. Further, you can simplify it. Values of a and b are given. So a is equal to 3. So this becomes 3x square plus 2 into 3 is 6. Bx square minus bx. Value of c is -2. So it will get you -2x. -2 into minus is +2. And further, if you simplify these two, it will give you 8. And then coefficient of x. Where are coefficient of x? This is x, this is x. So minus bx minus 2x, and the coefficient of x square minus 3x square plus 3x square plus bx square. Then further simplify this one. You can see here we are having 8 plus 2x minus x square. So 8 plus the coefficient of x. Because this is here we need a plus. So minus b minus 2, and take x as a common factor, plus you can take x square as a common factor and get 3 plus b x square. So now 8, okay, you can see that x and its coefficient, x square and its coefficient. So here, because we are having a negative sign, we can change this one into negative, and you will get 8 plus minus b minus 2x minus 3 minus b x square. Anyhow, we can compare the coefficient of x. So the coefficient of x here is 2, and the coefficient of x here is minus b minus 2. Okay, and simplifying this one, we get minus b is equal to 2 plus 2 is 4, and b is equal to -4. So this is the approach we have to use in solving these sort of problems. Therefore, the required partial fraction are, which was a over x minus 1. So a was 3. So we'll get 3 over x minus 1, and then plus bx plus c plus bx plus c over the quadratic part, which was x squared plus 2, x squared plus 2, and then you can further simplify it to get the final answer. So I hope you understood all these three cases. Now there is a fourth case which I will discuss later, and that is basically about finding the partial fraction of improper fraction. The improper fraction which we discussed in the beginning of this chapter. Your task for today and tomorrow is to do a question from exercise 7a and 7b. And I will also upload the final lecture as well, which is about partial fraction of improper fraction.